I'm Sam. I'm on Twitter at @SPBale in case you'd like to follow me. I'm originally from Germany in case you hear an accent. I'm currently based in New York. I have a PhD in semantic web technologies, so I've done a little bit of research on some formal stuff related to data, and then ended up doing a lot of data work, working with third-party healthcare data, and then moved into, because I had so many data quality issues with that data, I actually then joined a company that was working on a tool that would help detect data quality issues. So I kind of just like flipped things a little bit. As of last month, I guess I'm a consultant now, so I am doing my own thing. Very, very excited about that. And I'm also very free to do a lot of awesome talks and workshops and community events like this one. So it's pretty awesome. So let's get started. So in terms of the agenda today, I am going to give you a whirlwind tour, and I didn't count it, but it's like about 10 tools I think that I'm actually going to demo. So I'm going to give you a little whirlwind tour of the wonderful world of open source data quality tools in Python. I have a little bit of a categorization in terms of the different types of data quality tools that I'm going to look at. And I'm going to show you some prominent ones and demo some of those, especially the ones that are still in active development. In the second part, I'm actually going to deep dive a little bit more into Great Expectations, which is one of those tools, mostly because it's one of the most complex ones, but also because it's the one that I actually worked on and have the most experience with and wrote all the tutorials for. So I'm going to do a little bit of a deep dive. Depending on how much time we have, I might be able to do a live demo. If not, I'll just walk through things and show a little bit of and show some screenshots. And then we'll have time for Q&A too. Although honestly, since this is such a small group, I'd also be very happy for people to just interrupt me. I won't be able to see the chat, but if you just speak up and ask questions, like that's totally fine. Because yeah, such a small group, it's not going to get too chaotic. All right, let's get started. So in terms of the motivation, like why am I talking about data quality tools? If you work with any kind of data pipelines, either as an analyst or a data scientist or a data engineer, or the people at the person at the receiving end who looks at dashboards to determine metrics, sales, KPIs, whatever it is, you might have noticed that data pipelines and data workflows are a bit of a mess. Data pipelines are brittle, they often fail. Sometimes they fail loudly, which is great because at least you know that something's wrong. Sometimes they fail silently, which means you have some errors in your data that go undetected for quite a while. I think the most example everyone's seen, so experienced at some point, is, oh, the dashboard data has been stale and hasn't updated for the past week and no one's actually noticed. People were just kind of like, oh, okay, the numbers haven't changed. Surprise, surprise. And then at some point you realize that stuff actually didn't get updated, or numbers just changed all of a sudden and you don't know what happens. The other thing that's really interesting is that tacit knowledge about the data is sort of scattered among domain experts, technical experts, the code, the data. So data unlike software, although I do treat kind of data pipelines and data, you have a lot of workflows that are similar to software, but unlike software, it comes with a lot of knowledge about, oh, what does this actually mean, right? Where with software, a lot of times it's more about the functionality, and with the data is sort of about the meaning of what does this variable mean, or do we actually know that this field, like age, for example, is always going to be populated? Is this mandatory, and what does it mean if it's missing? So there's a lot of sort of tribal knowledge that's sort of distributed amongst people on the team. Maintenance of data pipelines is oftentimes consuming, expensive, it's morale killing. My favorite, I like to talk about the great Thanksgiving incidents of 2016, I think at this point, where we found out that one of our data deliverables was broken, and because it was the end of the month, because it was Thanksgiving, we ended up working all the Thanksgiving weekend just in order to fix everything, because some bug had snuck into the data and didn't go notice until we did data QA at the end of the month. kind of in the same vein as the previous point, documentation is often out of date and unreliable because data also changes, right? You have data that comes from, let's say, an engineering team, from a log file of your application, and they might just be, making changes to the software itself, making changes to the application, which then impacts how things are being logged. And maybe someone has taken the time to actually document something at some point, but because the data producers and the data consumers, or the data the data chefs and the data consumers are often sort of very separate. There's often not like the connection of, okay, we're making changes to whatever generates the data, and that means we also have to update how we're dealing with the data. So that is a huge issue. That all leads to trust in many data systems being very low. And I've definitely heard, people in an organization saying things like, oh yeah, we don't actually know if the dashboard is like really up to date, like we can't be 100% certain, and that erodes trust in the data, erodes trust in the data teams, which is not great, and is just like unpleasant for everyone and puts a lot of things in your organization at risk. So long story short, this is all the horror stories of why data is so difficult to deal with. And there's a plethora of tools nowadays that can help you a little bit with this. And that focus on data quality. So data quality is kind of a little bit of a big term. You might have heard of like the 6 dimensions of data quality: completeness, consistency, conformity, accuracy, integrity, timeliness, or some variation thereof. I am actually not going to talk about that today, because I'm going to focus on this sort of more practical, more hands-on aspect, because trust me, there's no data quality tool where you say, okay, just give me the completeness or give me the timeliness, without actually specifying what that exactly means in your data. Like, what column are you looking at, or what does complete even mean? How do I define the complete, right? Is an empty string the same as a null value, the same as the number 0, right? If there is an empty string, well, it is complete, as in it's not a null value, but what does that actually mean? So not talking about that, but really just talking about tools that can help you implement whatever your interpretation is of those different types of data quality, those different categories. So I came up with a categorization of the different aspects of data quality from again, from a sort of more of a tooling perspective. This is not complete in any way, and this is literally just what I made up. There's surprisingly little literature out there about data quality as such. There is, I think, exactly like one go-to data quality book. A lot of them are very like enterprise level, corporate, whatever. I am still waiting for the like O'Reilly data quality handbook, or the practical guide to data quality, and that's still not a thing. So I think as data is becoming more of a kind of central focus point of a lot of organizations, and that's only just happening over the past few years, as data engineering has become more of established discipline, as the data ecosystem or data tooling ecosystem becomes sort of has like the key players that are starting to bubble up to the top. You've probably heard of Airflow, DBT, Snowflake, obviously everyone's using it, Fivetran, Stitch. So there's a few things sort of bubbling up to the top now. As all that is developing, I'm pretty sure there is someone going to come with like a better classification of those tools, but that's kind of what I have come up with now. So the different aspects of data quality that I'm looking at and I'm going to talk about today are data profiling, data documentation, data validation and testing, data version control, and data cleaning. And I've sort of like roughly arranged them on the level of modification of the actual data. So you can kind of think of data profiling. I'm going to explain what those terms actually mean. Data profiling as like you're just looking at the data, you're not modifying anything, up to data cleaning where you're actually actively modifying and editing the data. So this is sort of the spectrum. again, this is kind of like, I'm using this sort of as a tool, as a working definition, just for the purpose of this talk. This is not like a scientific approach to data quality. All right. So in terms of the tools that I've been looking at, I focus on what I call kind of almost like single purpose tools rather than end-to-end data processing packages. So while DBT, for example, has a testing component, the purpose of DBT is not to implement tests, but it's a data transformation, data pipeline tool. So I dropped that. Doesn't mean there aren't any tools in here that kind of do a couple of things at the same time, but I focus on tools where the main purpose really is something around data quality. It's actually surprisingly hard to find a lot of open source data quality packages. The commercial space has grown really, really quickly. Not necessarily Python or open source, but like just commercial data quality. You might have heard of like in Monte Carlo, for example. There's another one that just came up that's called Light something that I literally just saw yesterday. So there's a bunch of tools coming up in this space, like platforms that are all SaaS products. So somehow like the open source space is not, there's no clear like winners there. A lot of the projects, as usual, aren't actively maintained. So I actually marked active projects with an asterisk. So, and I kind of loosely use the definition of like they have some activity in their Git repo in the past 6 months. Someone has done a release or someone has done something there. And also the ones that aren't like explicitly marked as inactive. And in terms of the demos, I'm just going to like demo the ones that are, that are somewhat active. So please do let me know if I've missed anything. Like I said, this is sort of, I just spent a lot of time Googling and clicking and downloading stuff and trying it out. I really like this talk because it's just like a whirlwind tour and I'm just demoing a lot of stuff. And I hope some of those look really cool and look really useful. And you might start using them in your whatever it is you're doing with your data. All right. In terms of the running example that I'm using for this, and if you've ever seen a talk by me, you've probably seen this example. I love using the New York City taxi data. So let's assume we have taxi data that has one row per taxi ride, and it's split up by month. And one of the columns gives you the number of passengers per ride in any given month. So in this case, we have the majority of these rides have single passengers, and then it just goes down 2, 3, 4, 5, 6, and we don't have anyone riding with 0 passengers, which makes a lot of sense because why would you have 0 passengers in your taxi? So let's assume this is our January 2019 data, and then in February 2019 we're processing our data again, and all of a sudden we see a bump like this, where we have a lot of rides with 0 passengers, which kind of looks really weird and looks like this does not accurately represent reality. So this is just kind of an example of like a very typical like issue that we find. All of a sudden some numbers shoots up and we don't know why. So what I'm going to do is I'm going to use this data, like the sample data, in order to show you how I can, with each of those tools, how I can sort of like write assertions or use the tool in order to be able to detect things like that. Cool. Let's get started. So any questions or any thoughts, comments, or anything so far? Otherwise, I'll just keep going.
Oh, sorry, I did have a question, Sam.
Yeah.
If you go back to the previous slide, so are you going to show us how, or, you know, because of that blip, you know, in February 2019, where all of a sudden the number of 0 passengers jump up, are you going to show us how you can track the inputs that actually produce that number?
Exactly. Yeah.
Okay. Cool.
There's actually multiple places where you can apply, and I'm actually going to show that when I'm diving deeper into Great Expectations. But I like that you said like track the input, where you can detect those things, because you could technically apply any of those tools at any part of your pipeline. You could either monitor your input, you could monitor the final result, right, of your transformation of your analysis, or you can monitor both, which probably makes the most sense. So you have lots of different places. I'm going to show like a fun diagram that shows where in like a real life project, we actually implemented Great Expectations across the pipeline.
Cool,
Yeah,
thank
that's a
you.
great question. Cool. So let's get started with one of my favorite tools, which is Pandas Profiling. Actually, let's hop over to the. So I'm going to do a little bit of a crazy jumping back and forth between the slides and the and my Jupyter notebook. I hope that this isn't too confusing. So first thing I'm actually going to start with is just profiling. So what is profiling? Profiling basically just means you're describing your data in some way. So the whole purpose of profiling is to kind of be able to familiarize yourself with the data and sort of see what the dimensions are, like how many columns does this have? How many rows does this data set have? What's the distribution of the different values? What are the min and max values in the data set? Because that allows you to well, it's part of exploratory data analysis. So it allows you to just like write your analysis because it means you have like an understanding of what you find in the data. And then it also allows you to actually write tests because the profiler basically outputs some of the numbers that, you know, you assume are reasonable and sort of the gold standard in the current data set that you have. So I am going to just load the two data sets real quick. So super simple. As you can see, we have vendor ID, pickup date time, drop off date time, passenger count, fare amount. We just have like 2, 4, 5 columns here. And I'm doing the same with my second data frame, which is the February data, which has exactly the same structure. And the first like very easy example of profiling is to use the describe function in Pandas. So if you're just loading a Pandas data frame and you use describe, you get a few descriptive statistics here. Super straightforward. It only works on the numeric field. So you have vendor ID, which interprets as numeric because the vendor ID is 1, 2, 3, 1, 2, and 4. So what it does. You have passenger count, you have the fare amount, and it gives you the quartiles, it gives you mean, standard deviation, et cetera. So this is quite nice if you're working with numeric data. However, you know, a lot of our data is not necessarily numeric. A lot of our data is also has a lot more going on, and we want to be a lot more familiar with it. So we can use something called Pandas Profiling. So Pandas Profiling is also just another Python library. Just pip install Pandas Profiling, and it allows you to create something called a report or profile report, where you literally just pass in your data frame, and that's it. And Pandas Profiling does everything. It's kind of amazing. It's like a very sophisticated version of Describe. So, and I think the best way to do this. Oh no! What? Oh, I know what happened. Of course, I did not activate my. Oh. Interesting. I did activate my virtual environment. I actually have this installed. 1 second, live debugging. I do have Pandas Profiling installed. Did I import it?
Pandas profiling can be a little finicky sometimes.
Yeah, that's interesting. Oh, I have to actually restart my notebook. I have Pandas Profiling installed. I tested this in this environment yesterday, and it worked. And then I shut down the notebook, and now it's no bueno. Okay, let me try that. Import. Otherwise, I'll just try installing it right there. That's so funny. Okay. I am going to try and just reinstall this real quick. Sorry about that. That worked yesterday.
Yes, the Pandas profiling is amazing. Very useful.
Yeah, it is. It is really great. So we actually did sorry, I'm just going to uninstall it and reinstall it. We actually did a project, an integration with Pandas Profiling. So Pandas Profiling now also spits out a Great Expectations test suite. Maybe if we have time at the end, or if things actually work, I'll be able to show that. Let me try that again. I'm going to reload, restart the kernel. Let's see what happens here. Okay, that is very interesting. So this is not working. Sorry, everyone. That did actually work. Okay, has anyone had that problem before? Something's up with my virtual environment or my Jupyter notebook. None of the libraries are actually loading. Oops. Let me just shut down everything. Start my Conda environment. I'm sure I don't have any other notebooks running.
The thing that always intrigues me about data is how do you identify a single source? Is it actually possible to have a single source of truth?
That's a great question. So the thing I find really funny about when you talk, oh, by the way, it worked. I just restarted, I reactivated my Conda environment and it worked. The funny thing with data quality and with like all the tools that I'm showing is you're kind of assuming that you know that one of the data sets that you have is actually correct. And you're building all your assumptions around that, which can also come back to kick your butt because I have definitely had a situation where we built tests based on an existing data set, and then later on we noticed that whatever we had in that data set actually had some issues that we weren't aware of. So yeah, I think I mean, other than doing manual review of data sets, like you usually have to do like expert review to just have someone look through a sample of the data at least and then hope for the best, right? Or you have some definition of a ground truth for some facts that are right based on your domain, right? For example, if you have something like height and weight entered, that no human can be taller than, let's say, 7'5" or something, right? The tallest human ever measured. Like you have some like facts that are just true in life, or some business rules, right, where you can actually very clearly say, okay, this should not be the case. But other than that, like if you just get data from somewhere, you have to kind of just trust that it is right and do the best you can, right, to ensure that it's right, that where you're using as your gold standard is kind of the right thing. Anyway,
if I may just share one point, the question you asked extremely important, but also touches on the distinction between a data scientist and a non-data scientist, the business stakeholders, the people who pay the data scientist salary. I was the data guy more than a decade ago for a Fortune 15 corporation. My job was to oversee, and I was one of the biggest, I was doing data science long before it was even coined that way. And it is, the answer to your question is, it is not about data accuracy, it is about data consistency. So if I presented a metric in front of the US Congress, which I had, in the future, when I got better and more accurate data, I could not report the number to be more accurate one. It had to be consistent with what was reported to Congress. You don't, so it is not, it is a career limiting move to be fully accurate. And while a data scientist will say, well, why is that? You always, go with the real data. Well, again, when you're running a major organization that is several $100 billion in valuation, it's not that you're fudging the data. It is about data. You have to be consistent, because even in a dashboard, you want to show how the needle moves. You don't all of a sudden 1 month say, oh, we're going to redo the whole needle. You have to show, it's like unemployment numbers. What is the level of unemployment? How do you define it? Well, the definition used in reporting unemployment numbers isn't exactly economically accurate. However, it is consistent with the way it's been presented for many, many decades, and we have to stick to it. It's almost philosophical.
No.
You definitely get into like philosophical conversations there, for sure. Yep.
I find it fascinating. I do. Yeah. Thank you very much.
Awesome. So I restarted my Conda environment and it now works. It actually finds all the libraries. That has never happened to me. That's kind of amazing. Like I just had that shell running. Anyway, so we have Pandas Profiling. So without further ado, I am going to actually show you the content we've been waiting for long enough now. So Pandas Profiling gives you like a really nice output of, remember this is the data frame describe method in Pandas. Well, Pandas Profiling sort of makes this really, really nice and gives you a either HTML or embedded HTML output for every single one of your variables, every single one of your columns. It gives you descriptive, some basic statistics about the data sets, the number of missing cells, duplicate rows, size in memory, et cetera, et cetera. And then for each one of the columns, it gives you lots and lots of details. So this is just the overview, as you can see, where it basically just gives you the, a few statistics. However, if you go to toggle details, if you click toggle details, it gives you a ton more stuff, including percentiles, min, max, histograms, common values, extreme values, et cetera, et cetera. So it gives you some really cool more details. And as you can see in this data set here, in this histogram, it already shows us that, okay, 1 is the most frequent number, again, back to our passenger count, and then it goes down to 6. So this is pretty cool. Net I ran on the first data frame, so the one was the January data, so the one was our presumably correct data, but who knows. But like in this case, I would say, like, knowing what I know about taxi rides, like this seems reasonable, but obviously you don't know 100%, right, whether this is reported correctly or whether this is processed correctly. There might have been some weird thing that actually made the ones a little higher than it should be, right? Or for whatever reason, whatever the taxi drivers like entered and however this is reported, like, might have been off. There's so many ways data can go wrong. You never quite know, right? You just have to kind of have like a combination of your domain knowledge, where you can say, okay, based on my knowledge about how people ride taxis in New York, and based on some surveys and based on some anecdotal data and whatever, like this seems reasonable. And then you can just like verify every single step in your pipeline, every single step in your system, and like just assume that, okay, this is as close to the truth as it gets. Anyway, so if we're now inputting, if we're putting the second data frame into our Pandas profiling report, it will spit out the exact same report, obviously, with one difference. So if we look at passenger count here, we can actually already see our spike of zeros. So even though Pandas profiling is not necessarily a data quality tool as such, it can help us with eyeballing. And that's really nice because like, at least based on my experience working with a lot of analysts at like pharma companies, for example, they actually told us as soon as they get our data sets, they spend several days just getting like descriptive statistics and exploring the data set and looking at it and running some numbers. And Pandas Profiling does some of that for you. So it helps you with your exploratory data analysis, which is really cool. Cool. So that was Pandas Profiling. So and I'm also just using that to introduce the just general concept of profiling, which is basically helps you with your like understanding your data. And again, as I said, like you cannot write data tests or ensure data quality without understanding your data. Like that's borderline impossible. Awesome. So the next tool, and I'm going to switch back to my slides here. The next tool we're going to look at is in the category of profiling and validation. So profiling validation is a super cool and powerful combination because you can probably sort of put two and six together. Instead of me having to say, okay, I know that this column should always be between 1 and 6, and like it should be this and should be that and should not be bigger or smaller than this. A profiler can give you that range, right? It can give you that value, those values, and then you can just automatically generate data tests based on those values. So it takes a little bit of the manual work and the manual sort of the thinking work out of it. However, again, as I said, like you should always review kind of what the profiler tells you because your gold standard data set that you're basing your profiling results on might also not be perfectly clean. So in terms of profiling and validation, we have a bunch of tools. We have TDDA, which I believe stands for test-driven data analysis. That allows you to specify and verify constraints on data, and it has some very lightweight profiling there, which is pretty neat. There's pydqc, which also does data profiling, and it shows you basic stats about the table, and then it compares columns between tables, and it compares tables for identity. So you can basically say, okay, are these two tables the same in, let's say, my source file and in the version that I have loaded to my database. TDDA is still in active development. pydqc is not. The other one I would also just throw in a category of profiling and validation plus some added documentation is Great Expectations. Great Expectations allows you to write the declarative tests. Like I expect this table to have between X and Y number of rows. You can get validation results from those tests. It outputs a report, which is basically the documentation of the current state of your data. And it also uses a built-in profiler to generate those kinds of tests. That all sounds pretty abstract, so I'm just gonna jump back to my notebook and actually show you what that looks like. And these tools, honestly, like if you're doing any kind of data work and you're not already using any of these and you're not like excited about, oh, I'm totally gonna try these out, then you know, you might want to reconsider because these are actually so neat, and I had such a blast just like working with them. So basically TDDA works. It's pretty straightforward. First of all, you call a method called discovery df, which basically just means it does the profiling. So your constraints are your profiling results. So in this case, one constraint would, for example, be the columns, the values in the passenger count column are between 1 and 6 if I'm passing in data frame 1. So let's just see what happens. This is also super fast. So basically for every field in your data frame, it gives you the constraints. They're super basic. So you have the type, it tells you it's an integer, and then it gives you min max, it gives you sign, so it's positive, negative, and it gives you max null. So super straightforward, pretty fast, pretty lightweight. Okay, and the next thing you can do is say, okay, here's my constraints. So my, in this case, January data file is sort of my gold standard. So for any other data set that I keep importing into my like database, for example, that I keep using my pipeline, make sure that that data set also adheres to those constraints, that it also matches those. So all I do is I call another method that's called verify data frame. I pass in in this case, data frame 1. So this is a null op. I'm just showing you here that the data frame matches itself. And then, yeah, I'm basically just saying what kind of type checking I want to do. The other option I have in the TDDA, it's called epsilon, which is a little vague, but epsilon basically means it's a threshold as to like how many rows can actually violate those constraints and it would still pass the test. So this is your wiggle room or threshold to kind of give it a little bit of fuzziness. So it doesn't have to be like 100% accurate, like an exact match, but you can have a little bit of a difference there. So as I said, I'm passing in the data frame 1. So based on the data frame 1 constraints, so this one should just all pass and be beautiful. And as you can see, all constraints pass because I'm just doing like a null op. This is just testing itself. However, if I now pass in the February data, so the one that we know has an issue, or we don't know yet, but we, suspect maybe it has an issue, and I run verify, again, using those constraints that I've created earlier, I can see that passenger count column has 2 failures and 3 passes, and it's telling me the min is different, which makes sense because it went from 1 to 0. And the sign in this case is also different. That's sort of just, a side effect because it happens to have zeros in there. So that's not considered all positive anymore. So we have 20 constraints now passing into constraints failing. So this is a super easy way to just have some, if you want to compare data sets to each other, or like I said, if you want to establish it, this is my gold standard and here's what I'm testing against each time. If you want to use this in integration tests, for example, anywhere in your continuous integration pipeline, that's with a gold standard test set, that's a really easy way to implement it. The other tool, like I said, is Great Expectations, but I'm going to do a little bit more of a deep dive there later on, just because it's quite comprehensive. So that was TDDA, which I think is super neat. Where is the tool? Okay, so pure data validation testing tool. So basically just allows you to write a test, allows you to say what you want, like what the constraints are, without actually giving you the profiling options. One of them, and I think I have 2 pages here. One of them is called Bulwark, which is a data testing framework that just lets you add tests on methods that return Pandas data frames. It has some built-in tests, which is really cool, and it also allows custom methods for tests, so you can just write your own sort of definition of what your test should look like. There's also Engarde, which is a precursor to Bulwark, kind of the same thing, not in active development anymore. It's been Bulwark is sort of the more active one. There's also one called Voluptous, and this is where it gets really funny. And there's one that's called Voluptous, which allows you to specify a schema specifically to validate JSON or YAML. So this is not for like Pandas data frames, but for JSON YAML. The example they're always using is Twitter API, JSON input, for example. They can use that for that. However, there's also a rewrite of Voluptous, which is called Opulent Pandas, which is a data frame focused version of Voluptous. And I've tried it out. It looks use it in exactly the same way. The only difference is that instead of a JSON object, you can pass in a data frame, an actual data frame. However, you can also turn, you'll see the gymnastics that I'm doing in order to turn my data frame into a JSON object. And then the final one is mobydq, or maybe Moby Data Quality. This is a data validation web app. It allows you to check for indicators. And this is kind of where we're slightly connecting back to our dimensions of data quality. So it actually does allow you to check for completeness, freshness, latency, validity. So it looks at it at the concept of data quality at a slightly more abstract level than what I've just shown, which is like, I want the number to be between 1 and 6. mobydq, I'm not going to demo because it's a huge web app to spin up. I'm just going to show a quick screenshot there. So let's jump back to Bulwark. Bulwark is also, I really like this. So Bulwark is pretty cool because it allows you basically any method that you have that processes a data frame in some way, and then returns a data frame, you can basically just add decorators. So I assume you're familiar with the concept of decorators in Python. It's basically just like, it's a decorator to a method that adds additional functionality to a method. In this case, you can literally just import the decorators and use the built-in methods, built-in decorators here. So you have has no nans, so it doesn't have any nulls in here. It has the shape, so this is rows and columns. It has values within range. This is where we get to back to my passenger count column. So you probably at this point have figured out what I'm trying to accomplish with every single example. So my passenger count column, I'm saying needs to be between 1 and 6, and these are inclusive. And then this is my method that I'm using the decorators on. In this case, I'm just loading a CSV file. This is the dumbest thing you could do. Obviously, like if you're doing any like more complex calculations in Pandas, for example, that, you know, I wouldn't even say makes a lot more sense, because you also want to test like the source files that you're loading. So you can sort of do use this in a lot of different contexts. So again, I'm specifying these things that I know about my data, again, compared to the profiler, or compared to something like TDDA, which does the profiling for you and then gives you those constraints. I have to type in those constraints myself. But, you know, depending on the kind of data that you work with, that is also totally useful. So in this case, again, I'm just doing a no op here. I'm just testing the January data that I know is going to pass. So let me just show that real quick. And what happens if the test passes in Bulwark, if all the tests that are specified by the decorators pass, you will get the data frame back. If not, it will throw an error. So let's see what happens if I throw the second CSV file at it. And we're getting an exception. So we're getting an exception, which actually tells us the passenger count has some issues in there. And it actually also prints every single row that doesn't match those conditions. I haven't actually dug deeper into Bulwark to see whether I can make the error output, or like the actual, you know, telling me what's wrong with the data, whether we can actually make that any nicer compared to like TDDA, for example, where at least it tells you which ones have failed. It still doesn't tell you why it failed. It doesn't tell you like what are the values that are violating my constraints. But this one is a little, at least has like nicely formatted output. I'm not sure if Bulwark, I haven't seen anything immediately that's just like it has like a nice output. But again, if you're using this in like a continuous integration sort of style context, at least like throwing an error and saying, hey, you're violating some of the constraints is a good place to start. Cool. The other option to use Bulwark, which is also pretty cool, is you can just import those checks directly and then just throw a data frame right at it. So you don't have to have your method with your decorators, but you're literally just using this straight off the shelf and pass in data frame. And again, same thing happens. You get an error here, or you get an exception because those assertions fail. Pretty straightforward, super easy to use. Depending on what kind of data and how much you know about your data and what kind of data you work with, Bulwark might be perfectly fine, right? If you know, okay, I want no null values and I want this shape and I want all this, and you know these are not changing and I don't need any profiling, like this is perfectly usable. Cool. So I'm actually going to show Voluptous now. Like I said, it's mostly aimed at JSON and YAML. So kind of object rather than data frames. I've sort of just like twisted its arm in order to also accept the data frame by just using a pydqc on my data frame. And all I'm doing is I'm basically calling a function that's called validate data frame. I'm specifying, so this is kind of the sort of basically the same thing that you're doing with Bulwark with your decorators, or TDDA with your, what comes out of your constraints. You're specifying the schema. In this case, I'm specifying a data type, and I'm specifying for the passenger count column, specifying my range, minute, max. Again, they're inclusive. The allow extra here basically just means I'm only specifying some constraints for 2 of those columns, and then allow extra columns, but I'm not going to worry about those. If you don't use that, it will just barf at every single column because it says there's no constraints. So you can basically just, have a minimal test by using allow extra. And then, like I said, I'm just like sort of twisting this to actually turn my data frame into a JSON dictionary, into a JSON object, and returning that. And again, in this case, data frame 1, you know the drill by now. It passes those constraints, right? We know that the values are between 1 and 6. So again, it just returns the data frame. That's how I wrote the method. However, if we're validating data frame 2, it gives me an exception. So, and this error output is actually pretty neat. It says there must be at least 1 for dictionary value, blah, 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 because I have a 0 in here. So that was Voluptous. And like I said, Opulent Pandas works the same way without having to do the gymnastics of the data frame. I couldn't get it to work, unfortunately, when I tried it out. I think it's so far behind in whatever versions of libraries it is using of dependencies that I couldn't manage to get it to work. Another example, like I mentioned, is mobydq. So here's just a quick screenshot of mobydq. So you can actually, I can make this a little bit bigger. You can edit what's called indicators. And an indicator is, well, you can see the example, completeness, for example, and you have a lot of ways to configure your indicators, and then it actually tells you it monitors your executions over time. So instead of just kind of being, the one thing that says true or false, like pass or fail for whatever assertion you're making, this is an entire framework that actually shows you how your data changes over time, or whether it passes or fails your test over time. So mobydq is pretty comprehensive. I haven't personally used it yet. It is pretty resource intense. So maybe one day I'll once I have a new laptop, I might embark on that mission. But also just an interesting sort of slightly different use case, I would say. So this might be more for like stakeholders, for example, who kind of specify like what they want from their data, or for more from like a, I wouldn't say non-technical, but like not necessarily the people who built the data pipeline. So this might be slightly different audience or set of users here. Great. Okay, let's move on to our next category, which is data version control. Literally the only tool that I believe exists there, other than using just straight up Git, is DVC. So DVC is built on top of Git. It offers version control specifically for data and for machine learning model. So DVC is really, really interesting because it almost violates my requirement of I want a single purpose tool, because it actually does a lot of different stuff, but you can also use it just for version control. So I'm only going to focus on the version control part. You can kick off your pipeline runs and stuff with DVC too, which is pretty vast sort of set of features. But at its core, it's DVC, data version control. If anyone's aware of any other data version control tools that are open source in Python, please let me know. I feel like DVC has just has the thing, like the market, and that's it. So and just to kind of explain a little bit why data version control, again, data might change, right? Even just your test data stuff that you're using might be changing over time, or every time you're running an analysis and you're getting a new monthly deliverable of, let's say, your sales data, and you're running that analysis, right? You want to be able to reproduce any pipeline that you ran at any given point in time, which when you're using data, again, it's very similar to software, but you always have the two components. You always have the data itself, and then you have the code that modifies, edits, analyzes, whatever, transforms the data, right? And you always have those two kind of moving parts, and you want to make sure they're, you're doing the exact same thing as it was whenever you ran it the first time. So your code, obviously, you just have regular version control. You can restore a specific point in time. However, for your data, if it just gets updated all the time, you want to make sure that you have some form of version control where you actually know what changed at what point, and you can restore prior version if you want to. So for data version control for DVC, I also only have screenshots. I did actually run this, as you can see, but it's sort of, I don't like using it that much. Like, it's supposed to be like super convenient, but somehow I haven't gotten, like, maybe if you're using it more, it's kind of maybe like Git, where it doesn't really make that much sense if you don't have like an active use case for it. So maybe DVC becomes like more sort of natural as you actually have a use case. But for me, it seemed a little bit clunky and not necessarily super useful. There's one cool feature I'm going to point out that I think is probably the most valuable one. So first of all, DVC, you just start with DVC init. What it does is it gives you a hidden .dvc directory in your whatever project you're running it in that has a lot of the configurations. So it's kind of like very, very similar to Git, basically. And then what you do is for every data file that you have, you actually add, so you don't use git add as you would if you're using Git for version control, but you're running DVC add. And the interesting thing that DVC does, it doesn't track the data file itself, but it creates a separate file, as you can see, with a DVC extension. And that's basically presumably your hash for that particular version of that particular file that we're using at that point in time. So the main benefit that I see and then you can, commit new versions, you can restore old versions, and you're basically interacting with the DVC file. The main benefit I see there is that DVC allows you to set remotes to sync data to. So instead of managing, so the problem is if you're managing your data via GitHub, you check in huge data files, right? You check in like massive CSV files or Parquet files or whatever it is. That's not necessarily what GitHub was designed for. It's not that great with big files. Everything is going to be slow. You don't necessarily want that. So the main benefit of DVC is allows you to put your data somewhere else. Most popular example, obviously, is S3, because we put everything on S3 these days. And then basically have DVC just point to that file, that version of that file in your remote storage, and you're doing your version control as is on your local machine and on your Git repository, and DVC just knows where that file lives remotely, and it doesn't bog down your Git repo. That to me is really, really, really cool. Again, DVC, ton of other stuff. Maybe I'll go a little bit deeper and explore that, but right now I'm just focusing sort of on data version control aspect. Cool. Okay, so that was data version control. As I said, if you have any other tools there, do let me know.
There are a few like Jenkins, but DVC is state of the art. That is the standard that most use. But which is traditional data files usually used for reporting and so on. It's different when you're dealing with big data, like seriously big data, and you are using deep learning models like TensorFlow extended and so on.
Got it. Sorry, and were you talking about, what was the other tool you mentioned? Jenkins?
But I don't think Jenkins works anywhere near as well as DVC. I think DVC is state of the art. Jenkins.
Oh, interesting, because I only know Jenkins as a continuous integration.
CI/CD. It's used in CI/CD. Yeah, but has.
Oh, interesting. I didn't know that. Okay, that's cool.
I haven't used it, so take it with a fault.
Yeah.
But DVC, that ability, just as exactly as you described it, giving you that Apple time machine ability to go back in time with the data, is very important for audits, data audit, model audits, and so on.
Yeah.
Do you ever get into a situation where you've got multiple versions of the same thing and you, well, hang on, I don't, you make changes and then you actually can't, you make multiple changes on the same day, and then it's actually very difficult to what am I trying to say there is well, I guess what I'm thinking of, the reason I'm asking, I'm not a technical person, I have to say, so a lot of what you've shared, Sam, has kind of gone over, but I'm hoping I'm going to learn through osmosis. But one of the things that I find that just in general, just in terms of documentation and changes, is that it's actually, when you say going into a design of something and you're making a small change in one part of a model, and then you go back and you might have, say you've got one big thing that you're building, but in order to build that one big thing, it's made up of multiple facets, right? You go in and you make one change to one aspect of that overarching model, and then you can't find it again, or oh, I'm not sure whether I'm explaining it very well, but I'm only bringing it up. Sorry.
Go ahead.
Well, I just kind of feel like sometimes, you know, when you make changes to data, because it's so detailed, it's very hard to, I mean, it goes back to the tracking. So in order to be able to perform any kind of version control, do you still need to point it to a particular, not just a point in time, but also to, because often changes don't just happen in isolation. You might make multiple changes across different areas at different times on the same day. So how do you know? Well, I don't know whether I'm asking
you've actually hit, yes, it's hard, and things can get very messy, especially when you have to go back and you have to audit that.
Yeah.
You're saving everything, not just by date, but also by time. So it's date time. And so there's that element of it. And then the changes that you make sometimes may not be just to the data, but the data transformations, but also to the model parameters and configurations. I guess the best way around it is make sure you have plenty of documentation for all changes.
But then you would have to painstakingly go through each document, wouldn't you?
Yeah, and
so technically, if you're in like a best case scenario where you're doing it right, where you're doing your data pipelines right, the way you should be running things is by always having sort of, and I feel like you might not be familiar with that necessarily, like in software engineering, you usually have something that's called a deploy, like you have a production environment. So generally what you do, you kind of like run your stuff locally on your machine and you make changes like incrementally and everything. But at some point, and again, like if you're doing it right, if you're actually sticking to the rules, you should be making a snapshot of pretty much everything that you're doing, and committing it to version control, and then deploying it as like a package of here's the data, here's the model parameters, here's like all the other code that you're doing, and put that into your whatever production environment it is, where it then runs and generates output. And technically, like all those different components have been snapshotted as that one production run. So I hope maybe that explains a little bit. And again, that's like best practices, and like the number of times people just run stuff on their laptop real quick and send off some numbers and then have trouble like reproducing what they did. Like, as obviously, you know, this is real life. This is not an ideal scenario. But in an ideal scenario, you would be basically like always running everything and sort of snapshotting everything, running it. That's a result. That's the official thing. And your snapshots are, you know, what makes things reproducible. Does that answer your question, perhaps?
Yeah, no, it does. I mean, I can see that when you're working on it yourself, but when you have multiple people working on the same project, how does that work? So all the changes, is it obvious who actually has made the change? So when you do the version control.
That's what you do, version control, yeah. Yeah, so in version control, if you use something like Git, for example, or also DBC, which is built on Git, every change, and it, again, like in an ideal scenario, like every change actually has like the author assigned to it. It is a little bit difficult. Again, like you have to have good hygiene and good sort of like best practices in terms of don't merge too many changes into one big, what's called a commit, because otherwise it'll be hard to kind of figure out what exactly happens. Use actual commit messages, use you know, what's called tags in Git to say, okay, this is the actual deploy, things like that. So yeah, that's again, where sort of like, I believe there is a golden path and there is like a way to do things, and then there's reality. And you know, those are not necessarily aligned. Just in the interest of time, so I would like to get just a little bit to Great Expectations. I have a few more minutes of content, and we can also come back to the conversation. I hope that's okay. Cool. Okay. So those were all the tools that I've shown, and I promise you there's one more outstanding, which is Great Expectations. Like I said, that's the one I actually actively worked on. I won't have time for a live demo, but I'm just going to go a little bit deeper just to show you kind of sort of, it's almost like representative for how you would be using these data quality tools in like a real pipeline. So maybe that also shine some light of some of the questions that you had regarding like the workflows and processes. So this is an extreme simplification of data pipelines. So in some situations, you might be getting a monthly data refresh. So again, going back to my taxi data, it's updated every month. You load that data, you have ETL pipelines, so you're transforming it, you're storing it somewhere in a database, and then you have some code that generates your data products, dashboards, or any BI tools or whatever it is. This is extremely simplified, but like at a high level, data comes from somewhere, it's processed, and then someone looks at it or it's used for something, right? These could also be machine learning pipelines, for example, right? But the output is some kind of data or information that someone will look at. The problem with that is that a lot of times when we have issues, again, just go back to this, when we have issues anywhere in either the source data or in our transformations, because people might have been making changes and not documenting what they were doing and they're actually not correct, you might end up with errors in your data products and your outputs that go undetected. So a better way to do this is to basically do your data validation at some point and alert if something's going wrong with your data validation, and then go through your and then actually build your data pipelines, your dashboards based on that. And in this case, Great Expectations is sort of the component here that does the data validation. If you want to get even better, and again, that kind of goes back to the very first question you had, I think, May, where it basically said you can validate your input data, you can validate your transformed data, you can validate pretty much anything and at any point in your pipeline in order to ensure that your data products are correct. So Great Expectations is a tool that does the validation. It allows you to create tests, again, based on automatic profiling, or you can write them manually. So kind of a mix of what we've seen with Bulwark and TDDA. And it also has built-in documentation called data docs, or some people call it data quality reports. So this is what a data docs, for example, would look like. It has a test suite of a bunch of tests. Again, just think back to TDDA. That's exactly where it says, look, 20 constraints violated, or 20 constraints passed, 2 constraints violated, and it will tell you that this expectation suite failed. in this example, again, we have a wonderful, human readable output of the assertion or the statement, or as we call it, an expectation that values must always be between 1 and 6. So again, having like shown you everything in that notebook, this makes perfect sense now, right? This is exactly kind of what we've seen previously. It just looks a little bit nicer. And it also tells you what the unexpected values are. So in this case, the unexpected value is 0. Cool. So Great Expectations is, again, another open source Python library. It creates a little bit more of a complex structure underlying. So as you've seen with the other tools that I've shown, there's like you import them in your notebook or in your code and you run it, and that's it. Great Expectations actually allows you to, or it creates a little bit of a skeleton for a directory structure that has a bunch of content. And most importantly, it stores all your what's called expectation suites, or the list of tests that you're running against your data in a JSON file. An expectation is literally just a statement. In this case, you can express it as a Python method. Expect column values to be between the column's passenger count. The min value is 1, max is 6. And again, like if you run that expectation, it gets stored as JSON in JSON output, and it can also be rendered to human readable format in your data docs. So it's all pretty cool. As I've already said, Great Expectations does allow you to scaffold expectation suites using built-in profiling. So basically what you do is you look at historical data here on the right, use a profiler. Again, you always kind of need another human to like make sure whatever that output is actually makes sense, right? Because your historical data might also be botched already. And then it creates those expectations. And then you can use those expectations to validate future data. And some might fail, some might pass. The last thing I'm going to show for Great Expectation is, first of all, Great Expectation, this is really cool. It like integrates with pretty much any database. So one of the advantages that it has is it doesn't just operate on data frames, but you can actually just connect it to your database and it will execute the queries in the database, which will make it significantly faster in a lot of cases than when you're doing it on the data frame. So it has like a lot of, it supports a lot of backends, pretty much any SQL Alchemy connection you can establish. And this is sort of an overview of like an example architecture of how you would be using Great Expectations. So this is a web app that does some data analysis and then provides, at the end, there's always a dashboard at the end. So you can see there's an app that collects the data into a Postgres database, gets put into a replica, sync with Fivetran and put into Redshift. There we're doing the first health checks. Then we're actually running a bunch of pipelines that do transformations where we're doing quality checks with Great Expectations at each point. And then after those transformations, we're checking the data again before loading it to another database that then powers NS3, that then powers the dashboard. So this is sort of how, and again, this is not necessarily specific to Great Expectations, but just any data quality tool or any testing tool would be used in a sort of pipeline. Just for time, like I'm done with my content anyway, so I am not going to do the live demo, unfortunately, but again, it's a Python tool. Like it's not that different from all the other tools that we use. And the major difference with Great Expectations is that it has a command line interface that allows you to just type everything on the CLI on your terminal rather than importing a notebook. But you can also use it directly in the notebook. So you have different ways of creating your expectations. That's it. We are at time. Any more questions? I'm also in the PyLadies Slack channel if anyone wants to ping me there and ask more questions. Otherwise, maybe